Have you guys all heard of Amazon's product S3? Yeah. Okay. Let's see. That's basically what I'll be talking about. All right. So I'm going to talk about their new service S3, as well as the Ruby library AWS S3. Oops. So S3 stands for Simple Storage Service, and it's basically unlimited storage of files, anywhere between 1 byte and 5 gigabytes per file. So basically, it's like if you could imagine your electricity at your home. The more electricity you use, the more you pay. It's the same kind of model. The more data you store and then transfer up and down, the more you pay. So the way that it's accessed is a REST and a SOAP interface for uploading files, downloading files. You can also use BitTorrent for changing permissions on files, pretty much like a remote file system. And again, it's unlimited. It's also awesome. No FTP. It's kind of like, yeah, the way I imagine it or see it is kind of like FTP for the 21st century, yeah? It's like using REST or SOAP instead of using just the protocol. It's more abstraction and much more flexible. So AWS S3 is a Ruby gem written by Marcel Molina. He's on the Rails core team. So, and it implements the full REST API to a T. So every bit of functionality is implemented, which is really nice. And it's really well written, so it integrates with Rails very well. It's written in the same kind of, they use the same patterns as they did in Rails. So using it is very similar to using a lot of libraries in Rails. So just to get into S3, the basic foundational container is called a bucket, and that contains all your files. So you can create as many buckets as you'd like, and inside of those buckets, you can create as many objects as you like, which are your files. They cannot, however, contain other buckets. There's just the low-level buckets which contain objects. That's it. That's how the whole architecture is laid out. Your bucket must be unique across all of S3. So if you create your own bucket called Jordan's bucket, there cannot be another bucket across the entire service called Jordan's bucket. The reason for that is because they're hoping that you'll use your bucket name as a virtual host. So you can just point your DNS at it, and that becomes your server right there, your file server. So your buckets have very flexible access control, so you can make everything public, read by everybody, or you can limit it to a username, password combination, anything. It's very flexible and can be virtually hosted, which I'll show you what I mean by that right now. Let's see here. Okay. How do I exit this? Okay. So here's my domain DNS controller right here, or control panel. So this is for my domain upload.ariasha.com. Basically what I did was, or that's the wrong one. That's okay. It's supposed to be static.ariasha.com. It doesn't matter. This is just for an example. But that's a subdomain of my main domain, and I just point that a CNAME record at s3.amazonaws.com. And what happens is Amazon AWS receives the request and looks at the host parameter in the header and sees that it's upload.ariasha.com and interprets that as the bucket name. And then how it figures out which object to grab is simply the path after upload.ariasha.com. So here's a product I'm working on that's actually using S3. And so you can see static.ariasha.com, and then the actual full object or file name is that image / whatever. And that's actually being served from S3.
So within your bucket, can you have a separate form structure?
No, I'll get to that right now. So it's very interesting how they chose to do this. inside of your bucket you can have objects, and they're similar to files on a normal file system, except with one exception. They're only contained within their parent bucket, and that's it. They can't be contained. I mean, like, there can only be one level of buckets, just flat buckets and then objects. And they obviously must be unique within a bucket, can have arbitrary metadata, and also have flexible access control, but they can have any name. So /dude, /yeah, /man.html, that's one object. And the reason they did that, well, I don't really know the reason they did it, but it's pretty cool because instead of dealing with a ton of directories, you can just say, find my objects that start with /dude/. So then it works just like a directory structure. It's just then you're manipulating strings instead of finding out if that directory exists or whatever. So it's just makes it a lot easier, in my opinion. Yeah. So yep, and yeah, exactly. And you can also create arbitrary buckets too. So if you wanted, yeah. So it's not guaranteed. Yep. So that's how objects work, and so the AWS library, AWS S3 specifics, it comes with a really nice shell, so you can manipulate your objects, change stuff while you're learning it, and then once you have a product running on top of S3, you can go in and just make sure everything's running well and all that kind of stuff. And it's really similar to, as I mentioned earlier, similar to Rails in design. You can see a couple examples here. To operate on a bucket, you just say bucket.create or bucket.whatever the methods are. And the same with object. S3 object.store something, file.read, and then in whatever bucket. The cost, this is the cost model. This is exactly how it is. There's no setup fee. There's no hidden costs, nothing like that. It's just 15 cents per gigabyte month, which means the average amount you've stored that month. So if you start out at 0, upload 7,000 gigabytes, and then drop it all off, the average is actually 0 plus 7 divided by 31 days or whatever. So yeah, you're not going to get away with something like that. And then it's 20 cents per gigabyte of data transfer up or down. Conclusion, I think it's a brilliant service at a really reasonable cost. Some examples are SmugMug, which is a photo serving service for professionals. It's kind of like Flickr, but more prone, or it's targeted at very professional level photographers and stuff like that. So they moved their entire data center over to S3, just tons of gigabytes of storage, like terabytes. And they saved $500,000. Was it 500,000? Did you read that article? I think it was $500,000 so far they've saved. What? Yeah, it was about $500,000 they've saved so far. And this has been out about 6 months or less. This has been out 4, 5, 6 months. Yeah. So they've already saved $500,000 using it. And it's built on a platform you can trust. I mean, Amazon's been through everything. They've been here since 95, 96, so. What happened? Oh, were they? Yeah, I mean, we've experienced one downtime a couple weeks ago, but it was just a short little, probably 20 minutes or something like that. And it really takes the pain out of having to build your own infrastructure, dealing with, once you have a pretty popular site, you're dealing with tons of uploads and where to store all these files and buying new hardware and all this stuff. It really takes that whole problem out of the picture. I was actually doing that, and then I read about Amazon S3. I was like, well, I don't need to do any of this now. So I just switched all over to S3. And so now we can play with the shell, and I'll show you some more examples and answer any questions.
I have a basic question.
Yeah.
I want to use the 2 that church thing for people that upload.
Yeah.
So I mean, you upload it to your server, process it, do all that stuff.
Yeah, I can show.
And then send it off with the rest to S3, right?
Yeah, I meant to make some diagrams of actually my implementation of it, but I can just show you some code. Yeah, well, I can show you guys some code real quick. Here's just an example real quick. Here, I'll just refresh this. Just to show you the performance. This is video. I'll just show you a cool little video. I mean, this is streaming right now. So. Have you seen this commercial? This is fun.
How would you handle if somebody wanted to upload a, 50 or 60 minute video or something like that?
They actually, it's streaming up and down. So
it won't time out and stuff like that on uploads?
no, it won't. And well, that's up to your. Here, I'll show you my implementation now. So I went with a. Let's see. So I have a dedicated server, which handles all uploads. It can handle video, images, documents, any type of upload. So I have a. Oh yeah. How do I just installed this. Does anybody know how to do that in this? Settings, appearance. Oh, my laptop wireless died. So, this is my girlfriend's computer. Okay, is that good? Sure. Oh, where did I just go? Okay. Is that good? Okay. So I just have one file process, and so I have my upload processors. I have the AWS S3 library, Digest 75, and MIME types. So here's the MIME type definition for a Flash video. And then here, you don't want to look at those keys. Those are mine. So basically what happens is I say, give me all the CGI parameters that are actually file uploads. And then if I actually have file matches, then I go through each one of them and create a new AWS upload processor object, which is specific. Let's say I'm uploading an image. Then it grabs a class that's called image processor and returns a new object of that type so that it can handle whatever I tell it, whatever I've defined in image processor, it will handle for that image. And I'll show you that in a second. So you can upload an arbitrary number of files on a single request. So let's say there's 10 files here, all different types. It'll handle all of them individually. And then I establish my connection this way. I've defined my Amazon keys above. So I establish my connection with S3. All right. And then I go through each one of these uploaders, which I just talked about, find out their type, and get the file object for each. And then just do some parsing. This is since this isn't a Rails app, this is a straight Ruby script. I have to somehow interface with my main Rails app to verify that this is actually coming from my Rails app. So what this does right here is I serialize the parameters that I have from my Rails app, and then I send a request off back to my Rails app and say, hey, is this actually coming from you? And if so, I have an upload to process. Give me the ID of whatever I'm uploading. So if I'm uploading an image, I say, here's the parameters you sent me. Do they match? And I have an encryption key that says, that only the server and the application know. So they just send a message back and forth. Yeah, it's valid. And then Rails sends back the ID of the new, the ID in the database, the new ID. And that's how I store the file name. So if you look at this image, this is the ID 26. and then I store that in S3 right here. So I go through each file, figure out the MIME type of it, and then I store an S3 object. Now, if you have a file handle open already, it'll automatically stream it. So you say file.open and then the path to the file. If you just pass it a path to the file, then it'll actually take the entire file, put it into a string, and then send it off at once. But if you actually give it an open file handle, then it'll stream it up. So then it's much more efficient. Then I delete the file on my server and end the connection and return back to Rails. So that's how that works. Let me show you this real quick. Let's see the processor. So here's my processor, like an image processor or a video processor. It's probably kind of hard to read, sorry. But here's just my image processor. So if I upload an image, then it hands back an object of this type, and then I tell it to process, and it does whatever it needs to do to an image. So I can create an arbitrary number of processors and just stick them in this directory, and they'll run, just for any type of file you upload. So that's how I've implemented S3. Everything is stored on S3, and then I just keep track of where it is, like what's the object name, and that's how it derives this.
Yeah, so like in the database, is it storing the whole
No,
string or just the ID?
it derives the ID. Yeah, it derives this URL from just the ID. Well, the ID and an access key. I created an access key because basically that's the MD5 hash of the timestamp at which it was uploaded, and you could never ever figure that out. So the reason I did that is so that you can't iterate over, like, if this was just 26.jpg, then you could just go 1 through however many there are and grab all my images out of my database, and then I don't have anything. So that's just an access key that's stored in the database. So it's just an ID and an access key, and that's it. And so we can go to that S3 shell if you want to see how that works. It's basically just like IRB. Yeah, sorry. See. So here's the documentation for the library. It's really good. Like, it's on par with Rails, obviously, because this guy's a Rails core team member. So establish a connection. Then we can go ahead and go service.buckets to look at which buckets I have. And, ooh, that's kind of hard to read. So I just have those 2 buckets right there. And then, so I can say static equals bucket find. So then I can go I have 111 objects inside of that bucket right now. So you could quickly see, how much space am I using, all that kind of stuff. Make a report.
Could you do something like figure out how much space
Yeah, sure.
per folder or something like that for a folder?
Yeah, I think the size
You
attribute.
could look for everything like in the beginning.
Oh,
right?
right. You mean the name? Like grabbing, say, all these objects that start with image. Is that what you're saying?
Yeah.
Okay. Yeah, the API really thought about, the guy really thought about everything for this API. Let's see.
Because I'm figuring we're probably going to get a lot more Basecamp storage.
Yeah, I think we can just go static and then say, does it start with a /? Oops. That was bad. see. Objects must have a find method as well. Yeah, that's the basic. That's basically how it works. You can look at these details all you want. I'll just send all these links on the mailing list, then you guys can check it out. So far, it's been pretty awesome. I mean, it's worked for me, and I hope to use it when I launch my product. Definitely. Yeah. Yeah, because I was like trying to build my own distributed file storage system, which is just crazy. Because I mean, I was using the same, dedicated server, but then I wanted to make sure I could, if I fill that dedicated server up again, or at some point, and then I want to buy another dedicated server maybe or something, I have to quickly scale to that. I have to just throw a script at that new server and be able to handle uploads and then fill that one up and move on. Because I can't delay my service just because I didn't think about my infrastructure. So now that takes that completely out of the picture. There's no longer a need to even build the infrastructure. So that's pretty much it.
That concludes this episode of the SD.RB podcast. See you next time.